Hello, my name is Laura Serra. I have a degree in mathematics and a PhD in statistics. In this video, I'm going to talk about descriptive statistics, which is a very interesting topic to be able to understand and go deeper into a more advanced statistical concepts. Just as an introduction, statistics are part of our everyday life. All one needs to do examine the baseball box scores in the newspaper or their bank statement, for example, of statistics. However, the idea of statistics is often anxiety-provoking simply because it's a tool with which we are unfamiliar. In this course, we will talk mainly about descriptive statistics, which are used to organize or summarize a particular set of measurements. In other words, descriptive statistics describe that set of measurements. Also, inferential statistics use data gathered from a sample to make inferences about the large population from which the sample was drawn. Inference is very important to be able to draw conclusions at the population level. In order to better understand how statistics work, it's good to define some concepts. On the one hand, when we talk about population, we refer to the set on which we are interested to draw conclusions. As I've said before, make inference. On the other hand, we use the word sample to describe the subset of the population on which we actually collect information or data. It's important that the selected sample be representative of the whole of the target population. Another essential aspect when doing statistics is to know very well the type of variable with which you can work. A variable is the characteristic of each subject, each case, of a database. It's called variable precisely because it varies from subject to subject. We can distinguish between qualitative and quantitative variables. Qualitative variables are those that have a quality or attribute of population. Within this type of variables, there are nominal variables, when there is no natural ordering among the categories. For example, gender, eye color. Ordinal variables, when things are measured in some order, such as cancer stage, student scores, or hypertension categories. And finally, binary variables, those that can only take two values, health status, sick or healthy. Quantitative variables, also called numerical variables, are those that take numerical values and represent some kind of measurement. These variables are often further classified as either discrete, when the variable takes one uncountable number of values, example, the number of prescriptions an individual takes daily, or continuous, when the variable can take on any value in some range of values. Common examples are height in inches or weight, pounds. In summary, an easy way to distinguish between one type or another, or at least it works for me, is to think the answer of the interlocutor. If the answer is numerical, how old are you? How much do you weigh? Then it is a quantitative or numerical variable. If the answer is a word, what is your favorite color? What is your civil status? Then it's a qualitative variable. Depending on the type of variable that we have, the exploratory analysis will be one way or another. In particular, measurements can only be made on numerical variables, while for qualitative ones, we will limit ourselves to tables and graphs. Exploratory analysis is essential in statistics because it allows you to describe the data and visualize how they are distributed and how they behave. It's the first step in your data analysis process. Here, you make sense of the data you have and then figure out what questions you want to ask and how to frame them, as well as how best to manipulate your available data source to get the answers you need. There are a number of tools that are useful for exploratory data analysis using visual and quantitative methods. First, the typical graphical techniques used, histogram column bar graph, a scatter plot. We will talk about it in the video about linear regression, or box plot. We will talk about it later on. A histogram and a column bar graph are useful when dealing with qualitative variables or even with quantitative discrete variables. These kind of graphs allow us to see the distribution of a particular variable. Contrary, a scatter plot allows us to see a relationship between two or more variables, both quantitative. On the one hand, the histogram represents the frequency of a qualitative ordinal variable. In particular, it analyzes the variable blood pressure, a variable with 4 categories: normal, pre-hypertension, a stage 1 hypertension, and a stage 2 hypertension. Graphically, you can quickly see which categories are the ones that include the most cases. Immediately conveys the message that the majority of participants are in the lower 2 categories of the distribution. However, in order to better interpret the results, the table is a good support that provides more specific information in relation to the values. These tables are named frequency tables and describe the frequency, the relative frequency in percentage, and the accumulated relative frequency for each category of the variable. Then, we can observe that the 2 first categories accumulate 75% of the cases. On the other hand, this column bar graph represents the frequency of a quantitative discrete variable. In particular, it describes the variable number of children in family. Again, through the graphic, we can see at once that the highest frequency is for 3 children, followed by 2, and then the rest of the values. Nevertheless, the table helps us to specify the values. The second part of an exploratory analysis includes the quantitative methods. We can distinguish between position measurements, which provide summary information of the variable under study, and the dispersion measurements, characterized for describing the variability or how far away the measurements are from the center in a sample of population. The mean, often called the average, is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data, although its use is most often with continuous data. The mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset, giving the value that is most common. But there are others, such as the median and the mode, with which we will make an example now. The median is the middle score for a set of data that has been arranged in order of magnitude. The mode is the most frequent score in our dataset. In order to calculate the median, suppose we have the following data. We first need to rearrange that data into order of magnitude, smallest first. Our median mark is the middle mark, in this case 56, marked in a red cycle. It is the middle mark because there are 5 scores before it and 5 scores after it. This works fine when you have an odd number of scores, but what happens when you have an even number of scores? What if you had only 10 scores? Let's look at another list of values. We again rearrange data into order of magnitude, smallest first. Only now we have to take the 5th and the 6th score in our data set and average them to get a median of 55.5. With respect to the mode, on a histogram, the mode represents the highest bar in a bar chart or histogram. You can therefore sometimes consider the mode as being the most popular option. Normally, the mode is used for categorical data where we wish to know which is the most common category. We can see in the graph that the most common level of studies in this particular dataset is the secondary. However, one of the problems with the mode is that it is not unique, so it leaves us with problems when we take 2 or more values that share the highest frequency. So when there are 2 values with the highest frequency, it's called bimodal, and if there are more than two, multimodal. Regarding the measures of non-central tendency, there are quartiles, which tell us about the spread of a dataset by breaking the dataset into quarters, just like the median breaks it in half, and also the minimum and the maximum value. Let's see an example. Consider the marks of the 100 students, which have been ordered from the lowest to the highest score. The first quartile lies between the 25th and 26th student mark, and the second quartile between the 5th and 51st student's mark, and the third quartile between the 75th and 76th student's marks. Finally, we focus on the dispersion measurements. These measures, also called measures of spread or measures of dispersion, and they are used to describe the variability in a sample of population. They give us an idea of how well the mean, for example, represents the data. If the spread of values in the data set is large, the mean is not as representative of the data as if the spread of the data is small. This is because a large spread indicates that there are probably large differences between individual scores. The main measures of dispersion are the range, which is the simplest measure of a spread and is computed by the difference between the highest and the lowest score in a dataset. The interquartile range, that describes the difference between the third quartile and the first quartile, telling us about the range of the middle half of the scores in the distribution. And the variance, which measures how far each number in the set is from the mean. Then, finally, there is the standard deviation that, as I have mentioned, it's calculated as the square root of the variance and is expressed in the same units of measurement of the data. If the data points are farther from the mean, there is higher deviation within the dataset. Thus, the more spread out the data, the higher the standard deviation. Measures of position and dispersion can be affected by outliers, which are values that distance from other observations. Outlier may be due to variability in the measurement, or they may indicate experimental errors. The latter are sometimes excluded from the dataset. An outlier can cause serious problems in a statistical analysis, so it's very important to be aware about them. Then, between the measures described, we can distinguish between robust measures, those that are not affected by outliers, and non-robust measures, those that are distorted by outliers. Then, we can observe that median, quartiles, and interquartile range are not affected by outliers, while the others are. Looking at the example, we can see measures of position and dispersion for two data settings in which the second group includes an outlier. We can observe how the robust measures do not change in both groups, while the others do, taking much higher values in the group with the outlier value. Finally, I would like to talk about the box plot graph. This is a graphical representation that divides the dataset into 4 parts with the same number of individuals. The values marked such division are the quartiles. This is a very useful graph for numerical variables that allow us to represent the minimum, the first quartile, the median, so the second quartile, and the third quartile, and the maximum. Also, it's a very practical tool to detect outliers. In addition, the interquartile range is well represented through the box, giving the idea of the dispersion of the central data of our distribution. Finally, let's interpret a box plot, also useful to compare differences between groups. In this example, we are comparing marks of 5 different subjects. Let's look at the following 5 cache diagrams, which represent the distributions of the marks of 5 subjects. Subject 1 to subject 5. Then, we see that the highest mark as a whole are those of subject 3 and the lowest ones of subject 4. In subject 3, more than 3/4 approve, while in subject 4 only approves a quarter. Subject 4, in addition, has an atypical value which gets 10 points. In subject 3, more than 3/4 approve, while in subject 4 only approve a quarter. The subject 1 is the one that presents a more varied notes. Between 0 to 10, we find everything. Subject 2, on the other hand, with the same median as 1, scores the majority of students between 4 and 6. Subject 5 has notes with positive asymmetry. The highest grades are very away from the median, and on the other hand, the lower notes are little. Thank you very much for your attention, and I'm waiting to answer questions or queries that you may have.